This is my fourth video lesson for the Ionic Bond unit. In this lesson, we'll be analyzing the chemical formula of an ionic compound. So go to page 11 in the class packet. Motivation. So here we're given a chemical formula. What do you think the number 3 and 2 mean in the chemical formula? So we will be discussing what those numbers mean in this lesson. Learning target. At the end of the lesson, I'll be able to analyze a chemical formula and determine the Lewis dot diagram of ionic compounds. For announcements, homework number 4 will be a junipod based off this lesson. The chemical formula represents a substance. It is a type of notation made up of numbers and atomic symbols. Here I have 4 different chemical formulas of 4 different substances: carbon dioxide, water, salt, and sugar. The purpose of the chemical formula is to tell us what elements are present and to indicate the amount of each element. For example, carbon dioxide has 1 carbon and 2 oxygens. Now let's analyze the chemical formula from the motivation. The 3 is a coefficient used to show the amount of molecules or atoms present. So in 3CO2, we have 3 CO2 molecules. The 2 is a subscript. It's used to show the amount of atoms of each element present in the substance. So here we have 2 oxygen atoms in CO2. Notice that carbon does not have a subscript. If you see an element that doesn't have a subscript, then the subscript is 1, because subscript 1 is invisible. So let's draw a particle diagram of 3CO2. It will look like this. We basically have 3 CO2 molecules. Now let's count the atoms. So we have 3 carbons and 6 oxygens. To count without drawing the particle diagram, you can multiply the coefficient to every subscript in the chemical formula using the distributive property from math. Can coefficients be fractions? You can take a moment to think about it, but the answer is no, because you cannot have half of a molecule, for example. Now we can talk about parentheses. So parentheses give an idea of the structure of which atoms are connected to each other. So use the distribute property to count the atoms. So this subscript 2 only applies to nitrogen and oxygen because they are in the parentheses. This 2 does not apply for calcium because it's outside the parentheses. So if you were to draw a Lewis dot diagram of this, it will look like this. Notice the parentheses tells us how the elements are bonding. We have 3 oxygen atoms bonded to a nitrogen, and we have 2 of these types of structures. So now let's count the atoms. So how many calcium atoms are present? By looking at the chemical formula, since calcium does not have a subscript, it is 1. We have 1 calcium atom. For nitrogen, nitrogen has a 1 here because it's invisible, so 1 times 2 is 2. Oxygen is 3 times 2, that is 6. So notice in our Lewis dot diagram, we have 1 calcium, 2 nitrogens, and 3 oxygens. In the future, we will learn how to draw this type of Lewis dot diagram. Check of understanding number 2. How many calciums, oxygen, and hydrogen atoms are present in this chemical formula? Pause the video and resume once you have tried it. So the subscript for calcium is 1, but the coefficient is 3. So 3 times 1 is 3, so we have 3 calcium. For oxygen, the subscript is 1, but it's in the parentheses. So 1 times 2 is 2, and since the coefficient is 3, 2 times 3 is 6. For hydrogen, the subscript is 1, but since it's in the parentheses, 1 times 2 is 2, 2 times 3, which is the coefficient, is 6. Learning check number 1. How many atoms are represented by the formula H2SO4? Pause the video and resume once you have the answers. Okay, so all we have to do is add them up. We have 2 hydrogens, 1 sulfur, and 4 oxygens. So that adds up to 7. So choice 3. Now we are going to discuss binary compounds. A binary compound is a compound with only 2 different elements. The prefix bi means 2. This is not the same as diatomic. So let's do a learning check. Which formula represents a binary compound? Pause the video and resume once you have the answer. Okay, so we're looking for a substance with 2 different elements. So the only answer that has two different elements is choice 3. So choice 3 is a binary compound. Choice 2 is a diatomic element. This is our first practice. I want you to count the number of atoms of each element given the chemical formula. For part 2, I want you to draw the particle diagram. So pause the video and resume once you complete this. Okay, so here's the answers. Now we are going to change topics and discuss how atoms might bond. So here we have oxygen and magnesium. Oxygen is a nonmetal, magnesium is a metal. So how might these two atoms bond with each other? We know that nonmetals tend to gain electrons and metals tend to lose electrons. So how many electrons is oxygen going to gain and magnesium is going to lose? So we have to use the octet rule. Since oxygen has 6, it's going to gain 2, and magnesium is going to lose 2. So 2 electrons from magnesium is going to transfer to oxygen. And when that happens, oxygen and magnesium will become ions. So magnesium is going to transfer 2 electrons to oxygen, and when magnesium loses those 2 electrons, it becomes an ion, a positive 2 ion. Since oxygen gained 2 electrons from magnesium, it's a minus 2 ion. We know from theme number 2, opposites attract. So since one ion is negative and the other ion is positive, they will be attracted to each other. That attraction is the ionic bond. So what word do you see in ionic? You see the word ion. So ionic bond is the bond between two ions, one positive and one negative. It's an electrostatic bond formed when valence electrons are transferred from one element, usually a metal, to another element, usually a nonmetal. To summarize, ionic bonding is the electron transfer from metals to nonmetals. Metals tend to lose electrons, becoming positive ions, while nonmetals gain electrons, becoming negative ions. The positive and negative ions are attracted to each other, and that attraction is the ionic bond. Ionic compounds are considered salts. These two terms mean the same thing. All ionic compounds are salts. All salts are ionic compounds. So here's an example. Sodium is a metal, fluorine is a nonmetal. Sodium is going to transfer one electron to fluorine. When that happens, sodium becomes a positive ion and fluorine becomes a negative ion. These oppositely charged ions will be attracted to each other. That attraction is the ionic bond. So here we have an ionic compound, NaF, or sodium fluoride. Now we are going to go over how to write the chemical formula for ionic compounds. So in ionic compounds, metal is always written first, then the nonmetal. For example, NaCl, or sodium chloride, notice that this metal is written first. Nobody calls it ClNa or chloride sodium. The total charge of an ionic compound is 0. It is neutral. Why is that? Because the charges, which is positive and negative, cancel each other out. So the conservation of charge is observed. The total charge of the reactants is equal to the total charge of the products. For example, when the sodium ion bonds with the fluoride ion, it forms a neutral compound. Notice there's no charge written for this compound. It is neutral because the positive and negative charge ions cancel each other out. So the total charge of the reactant is 0. Positive 1 plus negative 1 gives us 0. And since there's no charge written here, the charge of NaF is also 0. So you can see that the conservation of charge is observed. Here's another example with potassium and chlorine. Notice from the chemical formula, we only see one potassium and one chlorine. So when we draw the Lewis dot diagram, we draw one chloride ion and one potassium ion. So let's do another example in which it's not 1-to-1. So here we have calcium and 2 chlorines. In order for calcium to achieve the noble gas configuration, calcium must lose these 2 electrons. For chlorine, chlorine just needs to gain 1 electron. So calcium needs to lose these electrons to 2 chlorine atoms. Notice that the charge of chlorine is -1 because each chlorine gained 1 electron. For calcium, since it lost 2 electrons, the charge is +2. The total charge of this compound is 0. It is neutral because the charges cancel out. -1 plus 2 plus -1 is 0. You can also draw the Lewis dot diagram like this. Since we have 2 chloride ions, we can use the subscript 2 to represent that. Learning check number 3. Which compound contains ionic bonds? Pause the video and resume once you have the answers. Okay, so in order for a compound to have ionic bond, it must be between a metal and a nonmetal. So the best answer is choice 3. The other answers are all nonmetals. Choice 3 is a metal with a nonmetal. Learning check number 4. Which atom will form an ionic bond with oxygen? Pause the video and resume once you have the answers. So the ionic bond is between a metal and a nonmetal. Since oxygen is a nonmetal, we just need to look for a metal here. So the metal is potassium, choice 3. Learning check number 5. Which Lewis electron dot diagram represents calcium oxide? Pause the video and resume once you have the answer. Calcium oxide is an ionic compound, so the Lewis dot diagram should show charges. Since 1 and 2 do not show any charges, they cannot be the answer. Since calcium is a metal and oxygen a nonmetal, calcium will be a positive charge and oxygen will be a negative charge. If you look at Lewis dot diagram of 3 and 4, 3 drew the Lewis dot diagram wrong. The metal ion should not have any dots. Therefore, the best answer is choice 4. So this concludes the video lesson for today. Remember to do the Junipod homework.